Some time ago, I went to the junkyard for some materials, and there, abandoned, was this little orphan tube TV board. Well, since I was interested in taking out the flyback and the yoke coil, I brought it with me. And I already used those materials in another video, which you can watch by clicking the I up here if you're interested. But I still had the board with everything soldered onto it. You might think this is only useful for removing the components individually, but that's not the case. Papa Junta Mugre is going to show you today how you can do a bit of reverse engineering and remove entire stages to use in other projects. I know you won't find a board exactly like this one lying around, but I'm sure the tips I'm going to give you in this video will help you see how we can approach this recovery project, since all boards are pretty similar. This board is broken in two, but if we look, we can distinguish the very high voltage stage, which is where the flyback is located. Well, if you have some experience working with high voltages, you can do projects like that. In short, more advanced electronics projects. Today I'm not going to revive this high voltage power supply, but I am going to revive the main switching power supply that the TV had, which is this part. We can distinguish it by the following. Here we find the chopper transformer, which is this one. There's a high voltage electrolytic capacitor, this chubby one, this thing right here. This thing that looks like another transformer is actually a filter. It's called an EMI filter. It's to prevent electromagnetic interference. Also nearby, we're going to find an integrated circuit. Sometimes it's there, sometimes it's not, because sometimes it's made with transistors. But it's the one that generates the high frequency pulse that the power supply works with. And also, surely, on a heat sink, we're going to find a MOSFET. Well, I had to do surgery on the poor MOSFET because the board was broken right there and one of its legs was cut. Well, here you can see it. It's this one. Almost all of these power supplies already have the markings outlined on the silk screen below. Look, here you can see this mark. This one has it at the bottom and top on both sides, right? This is the boundary. Everything inside that marked area is the hot side of the power supply. There, when we're handling it with line voltage, we have to be very careful because that's not galvanically isolated. And, well, there's 220 volts from the line there, right? Outside of that mark, everything is safer. The voltages are lower. All right, here I'll show you another TV power supply so you can see they're all very similar. Here you can see the chopper, the big electrolytic capacitor, the EMI filter, the MOSFET. Also notice that the hot zone is marked off. I cut out the whole section with the Dremel so I could use the power supply separately later. I'll show you the rough cutting process I use when I remove whole sections intact, when I remove another section from this same board. In this case, it was a bit of work to get it running since it was broken, and I had to bridge the cut traces. And as I told you before, well, the MOSFET had lost a leg. So in general, it's always easier than it was for me because not all the boards are broken. These power supplies have several outputs with different voltages, but they're not power supplies like the ones in a PC. And, well, sometimes it's necessary to put a load on it so it stays on. One of the advantages these power supplies usually have is that they're very robust. And they're designed for heavy use, right? Just imagine that TVs could be on for hours and hours, right? So these are power supplies that are built for that. Now I'm going to show you live the voltages it has, how to test it, and all that. All right, here is the power supply. It's already separated. We're going to test it now. See that here you have the 2 pins where the 220 comes in. Here are some others that are a little smaller. These are for the switch. I've bridged them down here. See, I put a jumper there so it turns on. And, well, you always have to be careful to discharge this electrolytic capacitor beforehand. Right now it's discharged. You have to short it with a screwdriver. Look at the condition of the board. Here's the crack, see? And all the patches I made so it could start. These two are for the optocoupler, which is here. That's the tiny one that's here. Okay. And now we're going to test them to see what voltages we get. We always do it using a test lamp. A lamp in series, so let's put it here. The clips on the wires that go to the lamp in series. You'll see now. When I plug in the light bulb in series, you'll see that the lamp lights up at full brightness for a few seconds until this electrolytic capacitor is charged. Well, when we first plug it in, it's as if it acts like a short circuit. But it's not a short circuit. It just charges up and then it starts working normally. That is, it operates under normal conditions. I'm going to turn the board over so I can take the measurements. Always remember that in this whole area that's marked here, all this area on the inside, there's line voltage, so it's dangerous to stick your fingers in there. So be careful with that. We're going to measure here at the transformer's outputs. You can see here on the silk screen. Here you see the little diodes. They're the rectifiers. There are 1, 2, 3 diodes. We're going to have 3 voltages. Here, coming out of these pins. These are the pins of the transformer's secondary. All right, now I'll show you what happens when I plug in the series lamp. You'll see that it lights up. All right, like this. And there it goes back to its normal state. Now the power supply is working. You can even hear a little noise. I don't know if you can notice it. All right, give me a second. I'm going to set it up. Okay. Now let's measure the DC voltages and see. I'm going to measure across the 3 diodes, the ones I just pointed out, and you'll see the voltages we have. To ground, this is the ground. Ground, we have a voltage here of 27 volts. Another one here of 18 volts, and the last one of 19 volts. Those are the 3 voltages we can get from this power supply, which of course we can later regulate. With a 7812 if we want 12 volts, a 7815 if we want 15 or whatever we need, right? All right, let's move on to the next stage we're going to recover today, which is the audio amplifier. For this, we need to figure out which one it is. In general, they are integrated circuits. On the board, we will usually find several integrated circuits that have heat sinks. And, well, what we have to do is get a piece of paper and write down the names of all the integrated circuits and then look them up in the data sheet. In the data sheet, and find out which one is the audio IC, right? Well, I've already identified it here. The integrated circuit is the TDA7057AQ. It's a 2-channel stereo amplifier, 8 watts each. Just like I did with the power supply, I clearly mark the area where the components are located, the integrated circuit and the associated components. We mark it right there, and we're going to go at it hard with the Dremel. We cut it just like this. You can see it here, right? Well, it's so satisfying to cut like this. And when I use the angle grinder, it's even worse. Well, in those cases, there are always casualties along the way, right? Look here at how this electrolytic capacitor turned out. Here, I've already removed the little board. You have to scrape the sides with a file, the edges, let's say. Just in case, so that there aren't any traces left short-circuited from the cuts. And using the data sheet as a reference, we're going to solder the power cables according to what that data sheet says, right? Well, according to the data sheet, the power supply is from 4.5 to 18 volts. I'm going to give it 12 volts. And, well, now we have to find the pins. These are connected to the speakers. Well, in this case, it's pins 11 and 13 for one speaker and 8 and 10 for the other. Notice that sometimes, like in this case, the connectors are already in place, so you can just plug in the speakers, right? Because, of course, this was set up to work as an amplifier. So here you can see the two connectors. These two connectors, each with two pins, are where the speakers go, right? If by any chance you manage to save the speakers as well, we just connect them there. Normally, the scavenger who finds the TV thrown out on the street just smashes the tube, breaks it, breaks the neck, and takes the yoke with the copper coils. That's all he does after that. The rest doesn't interest him. So generally, they can recover not only the board, but also the rest of the TV, even the speakers. And if you're a fan of recycling, well, here's a video up here to see how to use the glass screen from those cathode ray tubes. Well, let's get back to what we were doing. All right, now we look at the data sheet, we identify the inputs, and we also follow the traces. There we can see that the capacitors are soldered, and from there we have to solder a wire that goes to a plug to connect to a cell phone or a Bluetooth receiver, whatever you want, right? All right, this is the little audio board. Look, well, based on what I read in the data sheet, I've already marked where the power supply goes, which are these two little wires right here. And we're going to apply 12 volts to it now. Then I also took the two speaker outputs. Look at this, because here, these two connectors you see here are the speaker outputs. So if you recovered the whole TV, that is, you can take out and plug the connectors directly here. And this way, both speakers will work for you. Then there are the inputs. The inputs are on the pin number 5, if I'm not mistaken. Pin 5. It would be 1, 2, 3, 4, 5. This is one that goes here to a capacitor. Notice that one of the wires that goes to a plug is also soldered there. And the other pin is the pin. Let's see. Which is the other one? The capacitor is there. It's number 5 and the... Which is the other one? Number 3, number 5, and number 3, those are the two pins that go to the inputs where I have a plug here to connect audio. And I'm going to connect audio here from a cell phone just to test, right? All right, let me see. Give me a second. I'm going to put it up here. Well, I've already connected the Bluetooth here. You can see the little cable going to the inputs, and we're going to play some music. Let's see this one. See, it sounds pretty nice. Let's try another one. Well, as you can see, it's simple. You just have to observe a little, and we can recover complete stages from the board, even if it's broken, like in this case. All right, friends, I hope you enjoyed the video, and whenever you see a TV lying around somewhere, don't leave it abandoned there, and you can practice these tips. That's all. Please give it a like and subscribe by clicking the bell to receive notifications. And if you want to support the channel, click the join button. And in that case, I'll add you to a WhatsApp group where the premium members are. Thank you so much for watching the video, and see you next time, God willing.